So until now, we have been going through the last way of all the different classes. So here we have read about what is actually called as S3. We have read about IAM as a part of security, as a part of storage. We have learned about S3. We have also learned about the EC2 section in very deep dive. Apart from that, we learned about what is Route 53 and then the databases. Now we are going to learn about how to create our own cloud, that is VPC, that is virtual private cloud. So how can we create our own virtual private space inside the AWS? So but before we go there are a few topics that are remaining that we are going to cover up in a little while after this VPC section, that is about the different types of load balancers, that is about ALB and NLB, that is network load balancer and the application load balancer. And in the Route 53, we are going to cover about the elastic caches in a practical part. So these are the couple of things that we are going to cover up in a few more days. But before that, we'll just get started with what is VPC. VPC stands for the Virtual Private Cloud. Now, this is one of the most interesting topics that I have found across the AWS. If given a little more time, you will love it, the way the VPC has to be set up, what is networking all about, and how do we play around with this. So we are going to learn about a lot of new things because most of us might be new to this networking background to understand what is CIDR block range, what is IP address range, how many IP addresses I get, how do we configure different kind of subnets, what are availability zones and other things. So it's a lot of new things that we are going to learn across in the part of VPC. But yes, given a time, you will surely love it, the way things are actually being set up in the VPC. So let's get started here. So in the part of our today's session, we are going to learn about what is called as VPC and how can we set up our own private cloud. So let's get started here. So as we all know, VPC stands for Virtual Private Cloud, and vendors like Amazon AWS or Microsoft Azure or IBM Rackspace, they are all the public cloud providers. So inside the public cloud, we are going to set up our own private space where we are going to have the resources which are limited to my company, and I do not want to expose it to others. Now, same is the case when I say it's a on-premise data center. So let's talk about one of the XYZ company. They have set up their on-premises data centers. Only the people who work in that specific company would have access to it, not anyone else in the world. Similarly, when I'm going to use this public cloud vendors like AWS or Microsoft Azure or anything else, I'm going to set up my own private space inside that public cloud so that only my company would be connected to that private space, and they will only have access to the resources which are going to get launched in that VPC. So AWS VPC lets you provision logically isolated section of the Amazon Web Services cloud where you can launch your AWS resources in the virtual network that you define. So we are going to define our own private network where we are going to launch our own AWS resources. It could be a EC2 instance, it could be a RDS database, or it could be anything else. You have the complete control over the virtual networking environment, including the selection of your own IP address range, creation of subnets, and the configuration of the route tables and the network gateways. So here we are going to introduce 4 different new terms, and let me put it across on this notepad. So the first is IP address range. Creation of subnets. And the configuration of route tables. And finally the network gateways. So we are going to learn in detail about each of these parameters here. So when we talk about the virtual private cloud, we do have a complete control over the IP address range that we are going to give it across for our VPC. We have a control over the subnets that we are going to create. We have the control over how to configure our own route tables, and we have the control over the gateways that we are going to create across. Now you can easily customize your network configuration for your Amazon Virtual Private Cloud. For example, you can create a public facing subnets for your web servers that have access to the internet, and place your backend systems such as databases or application servers in a private facing subnet with no internet access. Now what does this mean? Usually whenever we are going to build any application, it is usually either a 2-tier or 3-tier application, we call it as. Now what happens in the 2-tier? In the 2-tier we just have it as web application and then the database layer. And when we talk about the 3-tier application, we will have web application, and in between we may just have application, or we can call it as a middleware. And then finally we will have the database layer. So broadly, to classify, there are only 2 different types of applications that are usually built across. So either it can be a 2-tier application or a 3-tier application. Now when we talk about this, either of the applications, so web application layer is usually exposed to the people because it is going to be used across by everyone. Now the database layer is a really critical part for any company, and they would not like to expose it to anyone, or maybe is the case with the middleware as well as the database layer in the 3-tier applications. So what are we going to do? We are going to build the virtual private cloud in such a way that I will have multiple subnets, and inside these multiple subnets I'm going to define which is going to host a web application, so that I'll call it as a public subnet, right? So it has got access for everyone, so people across the world can access it. But database, I'm going to put it across behind something called as private subnet, so that people are unable to access it, and it's just limited only for the company's usage, right? So that's what we're trying to define here. You can easily customize the network configuration for your Amazon Virtual Private Cloud. For example, you can create a public facing subnet for your web servers. So I'm going to create a subnet which is going to be a public facing, which means I'm going to host my web application layer there, and I'm going to create a private subnet which is going to be just private to my company, and I'm going to put across my database layer there. Similarly, in this case, in the 3-tier application, we are going to put across web application in the public subnet, application and the database layer in the private subnets. You can leverage the multiple layers of security using the security groups and the network access control list to help control access to your Amazon EC2 instances in each subnet. Now, if you would like to secure this public subnet or a private subnet, how do we do it across? Now, whenever I'm launching an EC2 instance, we know that we have something called as security groups. But if I want to control it at the subnet level, we have something called as network access control list. We call it as NACL. So there are 2 ways or the 2 levels of the security which is going to help us completely secure the environment. Now you can also do one more thing. Additionally, you can create a hardware virtual private network connection between your corporate data center and your VPC to leverage the AWS cloud as the extension of your data center. So if you think you already have a data center at your company and you want to get connected to the AWS cloud along with it, so there are 2 ways. One of them is by creating a VPN connection, that is hardware virtual private network, and then it gets connected to the AWS cloud. Sorry. is data center, and using the VPN we are going to get connected to the AWS cloud. That is one way, or you can also use AWS Direct Connect. Direct Connect is only feasible for the places that are very nearer to the AWS regions. Like in India, we have it one in Mumbai. So if you are nearby to anywhere in Mumbai, you can actually opt for the Direct Connect, or else we'll have to use the VPN in order to get connected to the AWS cloud from our data centers. Now this is something that we are going to put across onto the part of our lab. So we are going to create a complete VPC like this, which is going to have something called as public subnet, which is also going to have private subnet, and the name of our VPC is going to be AWS training, which is going to be launched in one of the regions. You may select any one of the regions. Here it is in the picture, we are showing it as a US East one. So we may select any one of the regions from Mumbai to US, any one of them in between, we can select it across, and we are going to create a VPC with the name AWS training, which is going to have a public subnet and a private subnet, which is going to have a certain IP address range, and then we are going to create across the network ACLs to secure our environments, security groups to secure our EC2 instances, and then we are going to configure the route tables, then the internet gateways, and a lot more. Right, so this is the complete picture that we are going to actually put across. So now we learned what can we do with the VPC. So once we launch our VPC, I'll have my subnets, right? So if you remember from the point 2 here, I create my own subnets. So once I create my subnet, I'll be able to launch my EC2 instances in that. So here is my subnet. So this is called as public subnet, this is called as private subnet. So once I have my subnets, I can start launching my EC2 instances inside that, and then I'll be able to configure the route tables. Yeah, so before that, assign a custom IP address range in each subnet. Now that I have a specific IP address range for each subnet, I'll be able to assign an IP address to this EC2 instance. So I have a complete control over this EC2 instance on what IP address I want to give it for this. Configure the route tables between the subnets. So between these subnets, I'll have a route table which I'll be able to configure across and say what all traffic can flow across these subnets. Create internet gateway and attach it to our VPC. So we are going to create an internet gateway as shown here, and we are going to attach it to our VPC. Much better security control over your AWS resources. So we will have our better control in terms of our VPC, and then instances will have the security groups, and the subnets will have basically the network access control lists. Now before we go ahead and start doing the practical lab, first thing we'll understand here is what is the difference between the default VPC and the custom VPC. Now default VPC is something that you get by default whenever you're going to create an AWS account, and the custom VPC is something that we are going to practically launch it. So when we talk about the default VPC, it is very user friendly. It allows you to immediately deploy instances. So if you have seen all the labs across what we have been practicing until now, in terms of launching an EC2 instance, in terms of launching a EBS volumes, in terms of launching our databases or anything else, right? So we didn't have to do a lot of settings, but yes, the default VPC was always available for us to launch all of these AWS resources without any problem, right? So it was just easier to just select the default VPC and get started with any of the AWS service. All the subnets in the default VPC have route to the internet, so that is one of the best thing. So any subnet that you pick up in the default VPC, it will have access to the internet. Unlike the custom subnet where unlike the custom VPC where we are going to create the public subnets and the private subnets. So only the public subnets are going to have access to internet, and the private subnets will not have access to the internet at all. But in terms of the default VPC, any number of subnets you are going to create, everything will have access to the internet. Each EC2 instance usually had both the public IP address and the private IP address. So until now, whatever EC2 instances we were launching, it used to have both the public as well as the private IP address. And if you delete a default VPC, the only way to get it back is you have to contact the AWS. Now, let me show you by going into a specific region. I'll just open up the North. I have the North Virginia region open up. I'll go ahead and open up the VPC section here from the networking and content portion. Open it up in the new tab. I'll copy this and put across in the AP South one as well. So we'll just go ahead and open up a couple of regions here. Okay, there we go. So we have got the page loaded for our US East one, that is North Virginia. And we have also got it for the Asia Pacific Mumbai. And we have also getting the page loaded for our Ireland region a little while. Okay, in the meantime, let's check out the things in the Virginia and Mumbai. So you see that I have got one VPC by default, which is available. If I go ahead and click on your VPCs, you will see that there is one VPC already available. And here it says, yes, it's a default VPC. And if you are going to go ahead and delete this, you cannot get it back. So only way to get back the default VPC is you will have to go ahead and contact AWS. So do not make this mistake of deleting it, because if you delete this VPC, then you will not be able to launch any resource in the North Virginia, which means if you have lost this, you will not be able to launch any of the EC2 instances, nor databases, nor anything else. You'll have to create your own VPC and then play around with it. So if you, unless you do not have knowledge about the VPC, do not go ahead and remove this off, because it clearly says this is a default VPC that Amazon has given us for free. And similar is the case here. You see, I have one more VPC in the Mumbai region as well. So we have got one VPC in each of these regions. So whether I talk about the Ireland, whether I talk about the Mumbai, whether I talk about the North Virginia, each of the AWS accounts will have one VPC for the number of regions. Now, if I have got 15 regions overall here, so I'm going to have 15 default VPCs which are available. Now, there's something concept called as VPC peering as well. So now what happens in the VPC peering? Let's say I have got multiple VPCs. I will be actually able to go ahead and peer them up very easily. So if I want to have a couple of VPCs and both of them should be talking to each other, I can actually set up a connection between them by using the VPC peering. So VPC peering allows you to connect one VPC with the another via direct network route using the private IP addresses. So there are certain rules that we have to follow before we can go ahead and peer up the VPCs. And the instances will behave as if they were on the same private network. And you can peer the VPCs with the other AWS accounts as well as with the other VPCs in the same account. So it's both the ways. So if you guys also have some VPC in your AWS account and you want to peer it up with my VPC account, so we can do it, or you can also create the VPCs in your account itself, multiple VPCs, and then you can peer them up. So you have both the ways of peering the VPCs. So it can be either in your self account or it can be with your VPCs in the some other accounts as well. VPC is always done in a star configuration. So what is the star configuration? Let me show you. So this is how it is. So let's say I have got 5 VPCs, that is VPC A, B, C, D, and E. And if I want to set up a peering connection between each of this, so I'll have to manually go ahead and put a connection between each of them. So now in this case, VPC A is able to talk to VPC B. It is also able to talk to VPC C. It is also able to talk to VPC E and VPC D. Now let's say VPC B wants to talk to VPC C. is it possible to send the traffic via VPC-A? No. So VPC doesn't support the transitive peering. So sending the traffic from VPC-B to VPC-C via VPC-A is actually called as transitive peering, and transitive peering is never supported by Amazon. So we'll have to go ahead and create a manual connection between the VPC-B and the VPC-C. So in this way, we will be able to attain a connection between the VPCs. Remember, transitive peering is not supported. A direct peering connection has to be set up across either of the VPCs. So that was all about the introduction to the VPC. So any questions or doubts here from you, Divya, Rahul? So let's get started by doing a practical part of our VPC here. So I'm going to go ahead and get the first steps for how to set up the VPC. So we are going to keep up this diagram, and this is something that we are going to develop overall. Now, before we go ahead and start this, I'm going to basically use an analogy to compare how the VPC is built. I'm going to compare the analogy of VPC along with the land, buildings, home, etc. So I'm just trying to compare the VPC setup along with the way the buildings, lands or houses are being set up. So this is just an analogy to compare it and have a better perception of how the VPC is set up. So it may not be true completely, but yes, it does give us a sheer idea of how the VPC is actually set up using the land, buildings or home as a concept. So we are going to compare a lot of things in and around here. So let's get started. So I'm going to go ahead and pick up the steps for this VPC. Here we go. I have got the steps for this on how do we launch the VPC. So there are 6 steps in which we will be able to launch the VPC. That is the first part of our lab that we are going to do across in the session of today. So step 1 is to get started by creating a VPC. Now, as I said, we are going to compare the analogy with the land, buildings, home, etc. So now what you can think about VPC. VPC is, as I said, the name suggests it's a virtual private cloud. So whenever you're going to go ahead and purchase a land, it will be a private land, right? So it is going to belong to certain person. It's private to that specific owner. Similar is the case here. So I'm going to put across this analogy here. So let's say I want to go ahead and purchase a land which is of going to be maybe, let's say, of some acres altogether. So I'll just go ahead and draw this. So let's say I have purchased this land of 1 acre. And let's say we are going to pick up the Mumbai as a region for now, which has got 2 availability zones, right? So I'm going to go ahead and bifurcate this specific land into 2 portions, saying that these are 2 different availability zones. Okay, so this is availability zone 1, this is availability zone 2 for my complete land. So let's go ahead and pick up the Mumbai region here. Okay, here it is. Now let's click on, there are 2 ways in which you can go ahead and launch the VPC. So when you click on the VPC dashboard here, we have got 2 options, that is start the VPC wizard. That is one of the most easiest way of getting started with VPCs. Or you can also click on the VPC here and then say create VPC. That is the hard way of learning it. So we are going to look through both the options, the easiest way as well as the hardest way as well. So let's first check out what are the options available in the easiest way. So in the easiest way, as you see, there are 4 different options which are ready for you to get started with the VPC configuration. So one of them is a VPC with a single public subnet. Now, if you remember here, in the introduction part, we did say that we will be able to create our own subnets, right? And how, on what basis we are going to define it? It is based upon the type of applications we are going to build in our company. So if it's a 2-tier application or if it's a 3-tier application, usually the web application layer will be exposed to the end users. So I'm going to keep across my web application into the public subnet and the database across into my private subnets, which means database layers will be accessible only to my company people and not anyone else. Similar is the case here. So when I'm going to set up my VPC, I'll have either a public subnet or a private subnet. So the first one is we are going to set up a VPC with a single public subnet. So which means this subnet is there is only one subnet and which is accessible to everyone over the internet. The second is VPC with public and the private subnets. So I'll have two different subnets. One will be called as public, one will be called as private. So people from outside the world will be able to access this public subnet, and people within my company will be able to access only this private subnet. Now there is third one, which is VPC with public and private and the hardware VPN access. Now, as I said, private subnet is accessible only to the people in my company. How do they do it? Specifically, I need to have a connection between my corporate data center and the VPC, right? So we are going to get connected using the VPN here in this case. So VPN is going to help me connect to my private cloud, and in this I'll have two subnets, that is public subnet and the private subnet. Public will be accessible to anyone in the internet, and private will be accessible only to the people from the corporate data center. And I can also set up a kind of cloud which is accessible only to the people in the company, not anyone else outside this world, and that is called as complete private subnet with a hardware VPN access. So let me put it across here. Types of VPC. So VPC with public subnets, VPC with public and private subnets, then VPC with public and private, but we'll have a hardware VPN. And finally, VPC with private hardware VPN. So these are the 4 different types of VPCs that we can usually set it up across, and we are going to set up the second one, that is VPC with the public and the private subnets. This is something that we are going to learn across. Now let's get started here. So we are going to create a VPC. So as I just said, the VPC is just like going to go ahead and purchase a piece of land. So here I have purchased one piece of land which is going to be of size 1 acre, and since we are trying to use a region like Mumbai which has got 2 availability zones, so I'm just going to go ahead and bifurcate this land into 2 parts, which I'm going to term it as availability zone 1 and the availability zone 2. So the step 1 is about creating a VPC. So we are going to learn the hard way. The easiest way is very easy. So if I just go ahead and say, and then say select here, so it's just going to ask me a few things, and then the moment I'm going to go ahead and say that create VPC, it is going to immediately create it. So we'll not learn much things if we are going to do it the normal way. So we are going to learn it hard way. So I'm just going to go down to my VPCs here and then click on create VPC. So the very first part it asks me is the name tag. So what is the name of my VPC going to be? So I'm going to say that it is going to be AWS training as the name of my VPC. And then it's going to ask me for the CIDR block range. Now what is CIDR here? CIDR basically stands for classless interdomain routing. So when we call it a CIDR block, the block is basically a set of IP addresses. So I'll have an option to select a range of IP addresses that are going to be a part of my VPC. So here in this case, we are going to take up this example, that is 10.0.0.0/16. So I'll just pick this up. So currently we are going to use IPv4 CIDR block range, and the tenancy I'm going to keep it as default. So if you say dedicated tenancy, which means we are going to get a dedicated hardware inside the AWS Cloud Center, right? So we do not want a dedicated space in the cloud data centers. It's fine to use the default. If you go for the dedicated, you are going to be charged for that. So as a part of our free tier, we'll just limit everything to the portions which we can practice it for free. So I'm going to keep the tenancy as default. Now the new term that we have learned here is about something called as CIDR block. Let's put it across here. So CIDR, as I said, stands for classless interdomain routing. Now when I talk about the CIDR block, it is basically range of IP addresses. Now in this case, we have actually picked up a CIDR block range as 10.0.0.0 bar 16. Now we'll come back to what is 10.0.0.0 later. For now, let's understand what is bar 16 here. So usually bar 16 represents the number of IP addresses I'm going to get inside this VPC. So there is a formula or the way to calculate the number of IP addresses that I'm going to get in this specific VPC. So the formula is like 2 power 32. So this is the base here. Now since we have selected bar 16 and bar 16 is the highest in the Amazon AWS cloud, so if I go ahead and minus the number that we have selected for a while now, so it becomes 2 power 16. So totally I am going to get 65,536 IP addresses. So what did we do? Here we have picked up the range of this CIDR block, that is bar 16, and using that I have actually calculated the number of IP addresses I am going to get inside this VPC. So base is 2 power 32, so this is not going to change. So whatever number we have given, I'm going to go ahead and minus that. So that gives me 2 power 16 and it's going to give me 65,536 IP addresses. Now this actually means that if I have purchased a land of 1 acre here, in this I'll be able to actually create 65,536 houses. So as I just said, I'm just going to compare this analogy with the housing area. So VPC is like a private space. So in this case, we are actually creating a private space with this number that is 10.0.0.0, and I'm saying bar 16, which means in this complete area, I'll be able to set up 65,536 houses. And that's up to me. How do I create? Whether I create an individual 65,000 houses or whether I'm going to create buildings, and inside those buildings, I'm going to have the houses. So that's up to me. So this is the raw land, which is now actually termed as a VPC with the range. I'll just put it here, 10.0.0 bar 16, which means we are going to get around 65,536 IP addresses. Now, why we have chosen 10.0.0.0, we'll come back to that later. So going back here, so here it says CIDR block range cannot be larger than 16. So that is the maximum size that you can have actually in the Amazon AWS VPC. So I'm going to use this itself, 10.0.0.0 bar 16, and we are going to make use of IPv4 CIDR block, and the tenancy we are going to keep it as default. So I'll just go ahead and say create. So this is step 1 of creating our VPC. Now coming to the step 2, I'll have to go ahead and verify that the route tables are automatically created. So let's go ahead and check out. So here we have the route tables at the 3rd level. I'll click on this, and you see that there are 2 VPCs now I have in this Mumbai region. One is the default VPC that Amazon has created, and the second is the VPC that we have just created with the name AWS training. And there is one route table that has been automatically created, and it says this is the main route table for this VPC. Right? So each VPC can have only one main route table. We can create any number of route tables, but the other tables will be the secondary route tables, and there can be only one main route table for each VPC that gets created automatically the moment I am creating the VPC. Third, now we are going to go ahead and create the subnets. So what is a subnet here? So I'll just go down to the subnet portion. You see, I have already got two subnets for the part of my default VPC. And since in the Mumbai, I have got two availability zones, Amazon has actually created it with a simple design, trying to put across one subnet in each availability zone. And here if you see, it says it has got 4091 IP addresses. Similarly, what we are going to do is, we have got a VPC in which we have got a permission to go ahead and create 65,536 IP addresses, that is with the bar 16. Now we have to decide how many subnets I'm going to create. So subnet is a portion where I'm going to define how many houses can be created in that. So subnet is something like a building in this case. So I'm going to create two different buildings because we have two availability zones. I'm going to create two different buildings. One in each availability zone. For now, we'll keep the design very simple, first to understand the concept, and then we'll go ahead and expand it to a next level. So for now, I'm going to create two subnets since I have got only the two availability zones. So I'm going to create building number 1, and this is going to be the building number 2, or we can also call it as subnet 1 and the subnet 2. Now we are going to define how many houses this subnet is going to get across. So if you want to keep the extra area to be green in color, yes, we can add two different route tables, and we are going to do that in very next few minutes. Okay, so I'm going to go ahead and create those two subnets here, and it's up to us if I want to keep this area green in color with the gardens, swimming pools, or anything else, right? So I have complete control on how many IP addresses or how many houses I want to build across inside this building or the subnets. So let's get started here. So I'll go ahead and click on create subnet. So when I click on the create subnet, it's going to ask me the name. So I'm going to give the name to my building or my subnet. So I'll just give it as 10.0. Okay. Okay, so what I'm going to give in here is 10.0.0.1.0. I'll explain you why it is, and then the name of our VPC, that is AWS training, and this is going to be a part of one of the availability zone, that is AP South 1A. So I'll just give it as AP South -1A. So I just wanted to give it a very simple name, that is with the 10.0.1.0, then the name of the then the name of our VPC, that is AWS training, and then the name of our availability zone. Now we are going to create this subnet in the VPC with the name AWS training, which has got CIDR block range of 10.0.0/16, and the availability zone I'm going to choose it as AP South 1A. Now again, it's going to ask me CIDR block range. Now you have got this 1 acre of land in which you're going to build one building here and one building here, right? So I need to give again the number of houses that I'm going to create inside this building. So I need to give the block range. What will be the range of this block? So if it is called as a block A, how many houses am I going to build across inside this? So again, I have to give it something like this, 10.0.0/24, something as such. Since we have got a application with the 65,536 IP addresses, so I'm going to choose among it 10.0.1.0. I'm going to put it as 1.0/24. I'll just put it for now. So as I said, we'll learn about what is 10.0.0.0 later. So for now, I'll just go ahead and pick up this one. I'm going to say bar 24. So we have chosen to keep it as 1.0. So we'll learn about the first part in a little while. So let's understand what does bar 24 here means, right? Which let's go ahead and use this formula. So I put it as 24, so it becomes 2 power 8, which becomes 256, right? So 2 power 8 is value equal to 256. So I'm going to get 256 IP addresses in this case, right? So when I say bar 24, I'm going to get around 256 IP addresses, which means I'll be able to create 256 houses inside this building. So it's up to me within how many floors I create. It's irrespective of it. So I can create maximum of 256. Right, so this is our first subnet that we have just created. I'll just go ahead and say create this. And let's go ahead and create one more subnet. So this time it is going to be with the name 10.0.2.0 hyphen AWS training, that is the name of my VPC, and hyphen AP South 1B, because we are going to launch it in 1B. So I'm going to select AP South 1B. Here it is already selected as AWS training VPC, which has got CIDR block range of 10.0.0.0 bar 16. So this time I'm going to give it as 10.0.2.0 bar 16, and then just go ahead and say create it. Sorry, I'll have to give it as bar 24. So I'll just go ahead and say create this. So again, this has got 256 IP addresses, but now if you see here, it is actually showing that the available IP addresses is only 251. So there is a difference of the 5 IP addresses in this case, right? So where have those 5 IP addresses gone? So whenever we are going to create any subnet, 5 IP addresses in the each subnet will be actually reserved by Amazon. So we'll not have any control over it. So 5 IP addresses, Amazon is going to reserve it. So you are going to only get 251 in this case. Now if you check out the design of a default VPC here, he has created a CIDR block range with a bar 20, which means he is going to get around, if we go with the formula, it is going to become 32 minus 20, that is become 2 bar 12, and 2 bar 12 is basically 4096. But if you see here, it has got only 4091 IP addresses, which means 5 IP addresses are basically reserved by Amazon, and only 4091 IP addresses in the case of bar 20 are available for subnet. In this case of bar 24, we are going to get 251. So we have created what is called as subnets. Now we are going to create an internet gateway. Now that we have created our own land, we have got our own private land here. So who is going to have access to this private land? We have to define that. Right? Since this is a private cloud, or this is a private land, currently no one else will have access apart from the owner of this AWS account or the owner of this land. So what I'm going to do is I'm going to go ahead and define something like as internet gateway. So basically I'll have to put across a gate here. So once the building is ready, I would like to put across a gate, maybe either this side or maybe either this side of the building. Right, so I can put it across anywhere, maybe across this part or maybe across this part of the VPC. So basically we are going to create a gate so that people can access it from outside the world, so that they can come inside. If they have purchased some land or they have their own house in this, they can visit the place. So this is nothing but a gateway. Similarly, we are going to create an internet gateway. Why we call it as internet gateway? So that the people across the world, anyone can actually come through that space, or we can also go from this place to outside world anywhere. We should be able to access to anywhere in this world. So currently I'm going to keep it outside this scope. Currently we are not defining where it is going to be, but I'm just defining that I'm going to create a gate. So let's first get the design of gate created. So I'll go to the internet gateways. There we go. So I'm going to go ahead and click on create internet gateway. So it is going to ask me the name of this gateway. So I'm going to say AWS training hyphen IGW. Now the IGW is basically short form for internet gateway. So I write it as IGNW. So I'm going to create with the name tag as AWS training, that is the name of my VPC. And then I'm going to give it as name IGW. I'll say go ahead and create this. So now we have actually created a design, but now we have to attach this design, right? So the design of gate is already, so this is the design here for what we have on the diagram, and here in this VPC we have created it. Now we have to go ahead and say attach it to a VPC. So here in the drop down you can see that there's only one VPC which is available, which means each VPC can only have one internet gateway. It cannot have more than one internet gateway at all. So the design is ready and it is already attached to the VPC. So I have kept it near to this 1 acre of land, that is which is called actually VPC. So I have kept it near to it, but I have still not defined who is going to make use of this gate, which is going to be nearer to this subnet or this is going to be nearer to this subnet, right? So I just created the design and attach it to the VPC. So that is something like I have created a design and got it nearer to this specific area of land, and then I'm going to decide who is going to get this gate. So that is something that we are going to actually put across in the route tables. So we have attached the VPC. So 5 steps are done. So what did we do in the 5 steps? First, we created a VPC. Then we verified that the route table is available, which is the main route table for each VPC. Then we created subnets. Then we created the internet gateway. And finally, we attached that internet gateway to the VPC that we have just created. Now, finally, I'll have to define which subnet is going to have access to the internet, right? Or which subnet is going to get this gate nearer to it. So I'll go down to the route tables. I'll click on create route table. I'll name this as my internet RT, that is short form for again route table. I'll just give it as RT, and I'm going to create this route table in the VPC with the name AWS training, and then go ahead and say yes, create it. So we have created a route table, but we are going to define the routes. As the name itself says route, but I'm going to define the routes inside this. So let's go ahead and pick up the route. In this currently I have one default route which is automatically given. I'm going to click on edit. So basically I'm going to say add another route, and here it is asking me destination. Where would you like to go? I should be able to go to anywhere in outside the world, right? That is 0.0.0.0 bar 0. We call it as anywhere. Now using what I would like to go across? So using this internet gateway. So if I have this internet gateway, the people who are going to reside in this building or maybe inside this building, they can go anywhere in this world, right? So this is the gate from where they can go outside to any place. So that's what I've done. So I have given destination as 0.0.0.0 bar 0, which means anywhere in the world, any IP address in the world. And what I'm going to use, I'm going to use this internet gateway and then go to any destination. So I'll just go ahead and say save. So now we have defined the path to go outside, but who is going to get the access? So here is the place. So I have got 2 subnets or the 2 buildings. Here I'm going to define which building is going to get the gate nearest to it. So I'll say AP South 1A for now and then say save. So now it's finally decided that this gate is going to be the part of nearest to this specific place, right? So now it clearly says explicitly I have associated one subnet, that is this subnet is explicitly associated to this my internet RT route table, which has got path outside to this world, and this is not a main route table. You see here it is a no. So that is the complete setup of the first part of our VPC. So we have completed the 6 steps in which we have actually created this specific design. Now let's try to analyze this one. So what did we do? We actually chose one of the region, that is AP South one, that is Mumbai for us, in which we created a VPC with the name AWS Training that has got CIDR block range of 10.0.0.0/16, in which I created 2 subnets because we have got 2 availability zones in Mumbai. I have created only 2 subnets for now. One of them I'm going to define as a public subnet. So how can I say it is a public subnet? Because this has got access to the internet with the help of this route tables. Right, so with the help of this route table, I'm saying that this subnet is going to get access to the internet. That's why I'm calling it as public subnet. The other one is actually called as private subnet because this doesn't have any access towards the internet at all. Right, so this one is still associated with the private subnet. Let's see where it is associated. So if I go to the default route table of this AWS Training and go to subnet associations, you will see that it is still a part of the main route table, that is 2.0. right, 10.0.2.0 is still available there, which means it is a part of private, because the moment we are going to create VPC, which is actually called as virtual private cloud, which means actually it was private, I made it public by giving one of the subnet access to the internet gateway. Second one is not given any access. So we have actually created a route table and we have defined routes there on who is going to get what level of access, and we have actually also created an internet gateway, and this route table was actually mapped with a subnet and the internet gateway. So that is a design that we have completely set up for a while now. So any questions or doubts here, Rahul and Divya, from your side? So what I'm going to do is, we're going to stop the class here for a while because I do not want to put a lot of things in the day 1 of the VPC. VPC is a lot new where we learn about networking section. So I would like you to go ahead and practice this part of the VPC. So I'm going to put the steps in the chat box so you guys can go ahead and copy it and start trying to work out on the same. The 6 steps I have put across. So remember, VPC is not going to be charged unless you are not going to launch any resources inside it. So if you launch EC2 instance inside this VPC, then we are going to be charged for that EC2 instance. But launching this VPC is going to be completely free. But just remember that you have to select tenancy as default and not the dedicated. So if you select the dedicated tenancy, then later whatever resources we are going to spin it up, that are going to be charged directly because they are on the dedicated hardware. So just try to ensure that the tenancy you selected as a default, and you can keep the VPC as long as you want to keep it. There is no charges for creating a VPC. You can go ahead and create a VPC and play around with it for a while. In the part of tomorrow's class, I'm going to explain why did I chose 10.0.0.0 and what does this each number, we have 4 different numbers here. So what does each number in this specifically represent? We are going to talk about it. And we are also going to go ahead and launch one of the EC2 instances. That is, we are going to actually create one house inside each of these building. So we are going to create one small house that is like one EC2 instance. We are going to create, since we have got 256 IP addresses, out of which 5 are reserved by Amazon, so we will have 251. So I can create 251 houses inside this now. So what I'm going to do is I'll go ahead and create or launch one EC2 instance. One EC2 instance is equivalent to one house here. So I'm going to launch one EC2 instance, and then we are going to see how we can access it out from outside the world and how we will not be able to access this one because this doesn't have any gate nearest to it. So how does the private subnet behave? How does the public subnet behave? We are going to learn about all those things in the next part of our class.